Hello again. Uh, this is video number 3 of the AI sports referee, specifically the AI volleyball referee. In this video series, we want to see how we can apply AI on high-speed cameras and solve one of the issues that sometimes happen when you have a block touch on a volleyball game and no one knows if the ball touch or not the hands of the opponent. Sometimes it's really obvious that the ball touched, or something, but other times you need a video check for that when the human factor comes in and the referees want to see the video. But even with that, and even with a really big setup, like with 15, 20 cameras, sometimes you have a bad call about the block touch. So basically, we are trying to see if we can solve this with AI. This is our experimentation. In the previous videos, we showed about the setup, about the camera that we are using. You can check video 1, and how we can connect it on the NVIDIA Jetson Nano. On the second video, we showed also how we install the Bachelor camera software on our Linux machine, and we fired up the camera and we had the first footage of it. And in this video, video 3, we are going to show how we can control the camera inside the Python environment, inside the VSCode IDE. And now that we have connected the camera based on video 2, and we have the footage, then it is easier to get this inside, to get the footage inside the Python environment. And we are going to show step by step how we are going to do that. So let me share the screen and to guide you how you can do that. Okay, so first of all, we are going to start a folder inside our Linux environment, and then we are going to activate a Python environment there, because we definitely need to install a lot of libraries, but we don't want to mess a lot with the Ubuntu software. So basically, the idea here is to create a virtual environment. So whatever you want to do, you can do it at this virtual environment. If you make a mistake, you just delete it, and then you can start from the beginning without touching the software of the Jetson or in Nano. Okay, so here we can create a new folder. Let's say we can say that iCamera. So we can create this folder. We can go inside this, and we can open directly here at the terminal at this folder. Inside here, we're going to create a Python environment directly and activate it. We can do whatever we want to install inside this environment, and we don't have any issue with Linux machine. So we create the Python environment. One important factor here is to use system-side packages, and I will explain directly why we need these. And let's call our environment like Bachelor camera environment. Call it camera bus. The Linux is creating the environment, and when we create the environment, we need to activate it. So we are going to use the specific environment Hustler environment. When this gets activated, again, you see in the beginning that you see the environment, that you are inside the environment and you are using this virtual environment here. So we use the system side packages because even if we are inside the Python environment, we need this environment to sometimes call the libraries and check the libraries of the Linux machine outside. So basically, this small Jetson Nano has a lot of libraries that they are communicating with the GPU that is on top of the chip of the NVIDIA module. So if in the future we want to communicate with the GPU, then we need the Python environment to see all these libraries that they are installed outside of this Python environment. Here also, when you create a new Python environment, then you can do an upgrade pip. So you can if you don't have pip installed, then you can install it directly, or you can do an upgrade pip, and this will collect all the wheels that it is inside, and it will install the pip inside this Python environment. After that, you are ready to go to install the Bustler software inside this Python environment. So basically, you can do and this will draw directly the package pylon and will install it inside this environment. I have done this before, so basically it's here you don't see that it is downloading and installing. So basically, it's you have it in your memory right now, and it's installed in this Python environment. I am using VSCode to do all the experiments. So basically, if you are here at the Python environment, you can do directly, you can execute it, and then VS Code opens, activated, and using directly the folder that you have already created, the camera bustler environment. If you see below, it doesn't have, it doesn't know exactly what to use in what environment. So you can go inside this folder and create the first Python file, let's say main py, and it understands that you are at the camera bus environment. You can check it down here. If you don't see the camera environment here at the bottom right, then it is better that you go up here, right, Python interpreter, just see. You can do a Python select. You can check the Python select interpreter, and you can see below one of the options that it will say the camera bustler environment. You can select this, and every time that you are going to open your specific environment, the camera bustler environment, then this will open inside the Python environment. So every time you open the VS Code at this folder, you can check at the bottom right and see that you are inside. So if you want to deactivate it, you just do deactivate, but then whatever you do, it goes and it is installed at the Linux model environment and not at this specific one. So it's better that you are using and checking every time that you are at this specific environment. After all of this, you are ready to use your camera. So basically, let's go and find one of the folders that I have been working on the previous days and doing all of this work for the camera. I have been working at the past environment here. If you select it and you open it, maybe it didn't take exactly. Select. Okay, now we are inside the Bustler environment that I have been working in the previous days. We can check now. I have created a lot of Python files. One of the first files that I have created is a really simple Python file that you open the camera and you load the settings that you have saved from the previous session, so you can be sure that everything is working before. Let me also connect the LAN into the camera, so it starts working. We can go and see the Pylon software here. When the camera is ready, then you will see here one of the options at the gig cameras. It needs a starting time of about some seconds. So yeah, now it's popped out. So basically you double click it. And you just, if you want to check it and control it, you just hit this. And now we are indoors and the aperture was at a really high level. So if we do that and make it like f1.4, then you see directly, but more light comes in, and now you see inside my house, you see the couch and some chairs. Let me stabilize the aperture at the really low level, so we have a lot of light coming into the camera. So after checking the camera, then you have to click this button, so it disconnects from the camera and you are ready to go inside the VSCode and start working with the camera. Let's check some of the settings that I have saved in the previous session. You can check video 2 to see all the settings that we have saved there through the Pylon viewer software. Here you can see that the exposure time is like 4 milliseconds. This is kind of good for not so much light inside the room, so you can make it like 3000 if you have really good light, and we can experiment with that. Let's just leave it right now at 4. So basically we can have somewhere around 250 frames per second. This is more significant than the frame rate absolute that you can put below. It's like the camera is taking in using the internal clock to calculate how many frames it's going to use based on the exposure time and based on the width and height that you have selected on top. Other settings is the gain row, which you can translate it as an ISO of a DSLR camera. Probably most of the times, if you have very good light, it's better to leave it at 0. You don't have a lot of noise. And one other good option is the gamma. When you can, if you have really good light, you can put it like 1.5. With less light, you can put it 1.3. It's better like that. So let's see how we can use this file. You just open the camera and you load the PFS file that we saw a few moments ago. You just click run. And the settings are loaded, because every time you disconnect the camera and connect it again, then it loads with some default settings, and one of these are the frames per second. Usually you see like 50 frames per second. So it's better that you have the PFS file saved somewhere, and in the beginning you load the settings from the PFS, and you are ready to go. For example, if you have say want to go with 200 plus frames per second, then you load the PFS and you are ready to go. And the other file that I created, the Python file, is like open the camera, collect around 900 images at the period of 3 seconds. It's like more than 250, around 300 frames per second based on the exposure time and the width and the height of the image. And let's make an experiment and see how this applies to what we have done here. So let's comment these. So I have some time to go there to the couch and click it, and let's record the small video. Okay. This has finished. So let's open the folder that we have saved all of these images. So if you see here the statistics, you see that the camera finished at around, let's see, 4 seconds. The frames per second were like 800 plus frames per second, and this was because of the exposure time. If we make it like 3 milliseconds, we can hit 300 here. We can see this later, but the image will be kind of darker. And with this amount of time, it shoot all the footage and saved around 900 frames to the disk. So you see here the frames that we hit with at these 3 seconds. It's pretty cool, right? It has recorded all the movements. You can see me sitting down, you see just going back and forth, the previews and forth. But you know, the speed of myself is not very fast. Let's see the ball later. If I manage to capture that in this. Okay. Okay. Let's see also and change some settings here. See also more frames per second. Let's go and make that 300 so we can hit more frames per second. You have to load again the settings, so you can load the PFS file. When it's loaded, you will get loaded successfully, and then you can be sure that everything is working fine. So let's record again this video. You see here that it did around 4 seconds and we hit around 200 frames per second. Let's see what it had recorded. You see the image is kind of darker now. It's pretty cool, right? You see like this, you see until 150 images is like half a second. So this is pretty cool. It's like you see how the ball is rotating and captures all the details here. So that was it. You can experiment after you install and create your virtual environment. The video 3 was about creating the virtual environment and starting over. Creating the virtual environment and installing the PyPylon software of the Basler manufacturer. If you have installed also the Pylon viewer, then you can check the camera there and see where you can shoot like this. So basically you can go and open with this shift here, and then you can check the footage and see what you can check it every time, what you can see every time with the camera. And after that, you can just close it. You can stabilize the camera whenever you want. And you can go to the VSCode where you have open the folder and check at the bottom right that the virtual environment is active. You are loading the settings from the previous session, so you can be sure that you are shooting at your setting that you want, like gamma and gain and the black settings, and of course the exposure time, and then whatever Python file that you have created, you can use directly the PyPylon software, and you can import the library in the beginning. You can use it directly, and you can create your own script to save all the frames or whatever you want to do. You can create also a video, and then you can extract the frames with the FFmpeg library. That's all. Thanks for watching, and let's catch up to the next video when we are going to see how we can track the ball with a computer vision algorithm and check the center of the ball at every frame that we have set. Bye-bye for now.